Okay, identifying and representing functions. Sometimes you might hear the word function, and really they're going to be saying relation. Function and relation mean the same thing. They are interchangeable. Okay, so your questions might say, identify whether or not it's a function, or identify if the relation is a function. So just know that those are kind of the same thing. Okay. The x values of a function, those are called the input. The x values are the input, and the y values are called the output. And when you identify if something is a function or a relation or not, it's pretty simple. Okay, there's going to be 3 different descriptives here, but it really is kind of all of the same thing. So to identify if something is a function, then the x values never repeat. The x values never repeat. Another way of saying that is for each input, there's only one output. Or another way we could say that is for each x value, there's only one y value. And functions or relations can be represented in 4 types of ways. We're going to look at all 4 today. A mapping, a graph, ordered pairs, and tables. The first one that we're going to look at is the graphs here down at the bottom. In order to determine if a graph is a function, you're going to use what's called the vertical line test. So with your arm, show me what a vertical line looks like. Vertical line is straight up and down, kind of like when you're standing up. So draw yourself a vertical line just so you know what it should look like. Okay, vertical line is straight up and down. And my line's not very straight, but it should be straight. And what that means is if you draw a vertical line on a graph and it only crosses that graph one time, wherever you draw it, then that means it is a function. And if for some reason you draw a vertical line on a graph and it happens to cross 2 or more times, that means it's not a function. And I'm going to show you what that looks like with our examples here. So if a vertical line crosses 1 time, that means it's a function. If it crosses 2 or more, it's not a function. So with my first graph right here, if I drew my vertical line right here, if I drew my vertical line right there, how many times does that line cross my graph? It crosses 1, 2. 2 times. According to a vertical line test, is that a function or not a function? Not a function. Now, you might be wondering, well, if I drew my vertical line right here, it's only touching 1 time. Yes, that's true, but if you draw a vertical line anywhere on the graph and it touches more than once, it's not a function. Okay, so just because you draw a line here and it only touches once, that doesn't mean anything. Because when I draw my line here, or here, or here, it is touching more than once, so it's not a function. On the next one, if I drew my vertical line here, how many times does my line cross the graph? Just 1 time right here at this point. So is that a function or not?
Yes.
That is a function. All right, and on the next one, if I drew my vertical line here, how many times is my line crossing the graph? 2 times. So is that a function or not a function? Not a function. Questions about the vertical line test? and how to determine if a graph is a function or not. Okay, it is possible that you will see a graph that doesn't just have points, that it actually has like one continuous line that doesn't change the problem. Okay, so for example here, like this graph, instead of just having points, it could look something like this. Okay, and if we did a vertical line test, it's still just crossing at that one point, so it's still going to be a function. Okay, if you have something like this one that's continuous instead of just the specific points, it might look something like this. And again, if we draw our vertical line, it's crossing 2 times, so it's still not a function. So don't freak out if you see something with points or with a continuous line. You're still going to do it the same way. All right? On the back, at the top, these are mapping diagrams. This is just another way of representing ordered pairs. Okay, so all we're really focused on with a mapping diagram is I just want to look at my x values. Okay, I don't care about the y values. I just want to focus on my x values. So what this means is if there's one line coming from it, that means it's only being paired with one number. Like 1 is being paired with 2, 3 is being paired with 4, 5 is being paired with 0, 7 with 6, and 9 with 8. All I care about is that these x values are different, they're not repeating, and that there's only one line coming from each x value. When that happens, like this, that means it is a function. Okay. Now, on the second one, again, I only want to focus on my x values. My x values are 2, 4, and 5. They're all different, which is good. But I notice right here with the 2 and with the 5, there's 2 lines coming from those numbers. That means 2 is being used twice and 5 is being used twice. 2's with 0, but 2's also with 8. And then 5 is with 4, but 5 is also with 6. When it looks like this, and those x values are being used multiple times, that's not a function. And then on the third representation, again, I'm just focusing on my x values. Are they all different?
No. Yes.
2, 5, 6, 9, and 11. Yes, those are all different. Is there only one line coming from each x value?
Yes.
Yeah, that means it's only being used one time, so is this a function or not?
Yes. Yes.
It is a function. Yep, we're just focusing on the x values. I don't care about the y's. The y's could be the same for every single problem. It doesn't make a difference to me. I'm just focusing on the x values, or the input values. Questions on mapping? Moving on to tables. You might see tables that are horizontal, like this, or you might see tables that are vertical. You're still going to do them the same way. Okay, so if we look at our first table, again, all I'm focusing on here are my x values. I just want to make sure that they're all different and not repeating. So I have a 2, a 6, a 7, and a 9. None of those are repeating, so that's a function. On the second one, again, I'm just focusing on my x values. I have 3, 4, 4, and 5. Is that a function? Why? My 4 is repeating, so that's not a function. And then on the third one, I'm only focusing on my x values again. So, 0, 1, 2, and 3. Is that a function? Yes. Questions about tables? All right, last section. Ordered pairs. Same thing. It just looks different, right? So all I'm going to be focusing on are the x values. Remember that the x values are the first number in the ordered pair. The x values are the first number in the ordered pair. So I'm looking at the 4, the 5, and the 5. Is that a function? Yes or no? Why not? 5 is repeating. So this is not a function. Next one, again, all I care about are the x values. 1, -1, and -3. Is that a function? Yes or no? Okay, so I think someone said no. If you have a 1 and a -1, those are different numbers, right? That's like you have $1 in your pocket versus you owe someone $1, right? I'd rather have $1 than owe someone something. So since they are all different, that is a function. And then our last one, we have the x value of 3, 5, and 3. So, is that a function?
No.
Why?
Because the 3 is repeating.
It's not a function because the 3 value is repeating. Any questions about ordered pairs? Or mapping, or graphs, or tables? Okay.